So I have a question for everybody. Have you ever had the experience of driving in the rain and the fog where you strain your eyes to try and see what's ahead? You can't see very far, and what you can see is blurry and unclear. And then suddenly you drive out of the storm into bright sunshine and beautiful blue skies. You can see for miles and everything is crystal clear. Well, that's exactly what the Hubble Space Telescope did for astronomy, astrophysics, and cosmology. Launching a telescope above the veil of the Earth's atmosphere to see deeper into the universe than was ever before possible has been a transformative and eye-opening experience for astronomers and the general public alike. The Hubble Space Telescope launched 30 years ago in 1990, and it has forever changed our perspective of our place in the universe and our understanding of the cosmos. Tonight, you will meet the last astronaut and astrophysicist, indeed the last human, to lay a gloved hand on the Hubble Space Telescope back in 2009. You'll also meet an astronomer, astrophysicist, and educator who studies the growth of supermassive black holes and their coevolution with galaxies using a variety of different space telescopes. So good evening, ladies and gentlemen, and welcome to what is now the fifth installment of our now virtual SETI Talks. This is the monthly lecture series produced by the SETI Institute in Mountain View, California, where none of us are at the moment. I'm Bill Diamond. I'm president and CEO of the SETI Institute. We're a 501c3 nonprofit research and education institution whose mission is to seek out life beyond Earth and understand and explain its nature, origins, and evolution. Like most of you, we're currently doing our work from home, as you can see, but our research, education, and outreach programs continue unabated. Our SETI Talk series has been going on for many years, and we video record every talk, including tonight's presentation. And you can find all of our talks on the Institute's YouTube channel, where more than 400 amazing presentations on a wide range of space science topics await you. While our studio audience is joining us this evening on Zoom, I'd like to also say hello to and welcome to those of you watching our live stream on Facebook or YouTube tonight. So thanks to everybody for joining us. It's going to be a fun and very special evening. As we do at every talk, we like to poll the audience to find out who's joining us for the first time. And because now, since we're doing these talks virtually and not in the auditorium in Menlo Park where we normally do this, we're able to reach a global audience, which is really great fun for all of us. So you'll see on your screen now a little pop-up with a poll. This is really only going to show up on the screens of those of you joining us via Zoom. But it'll ask if you've ever attended a SETI talk before, yes online only, or no. So let us know, select the answer that fits and hit the submit button, and we'll share the results shortly. And now that we're virtual, we're able to engage a worldwide audience, and we'd love to know where you're watching from. So if you're on Zoom, use the chat function to tell us where you are, or on Facebook, let us know in the comment section. It's just amazing to see that we typically have people joining us from the far corners of the globe. And I'm sure tonight will be no exception. So please let us know. So tonight we're taking you to the stars and beyond with two amazing guests and a conversation that will be moderated by our own Molly Bentley. Molly is the executive producer of our own radio program and podcast, Big Picture Science, produced at the SETI Institute. We'll have time for audience questions after the main part of the conversation, and these will be handled on Zoom via the Q&A function that you'll see at the bottom of your screen. We may not have time for all your questions, but we'll do our best to address the most intriguing. So be intriguing. So with that, it's time to buckle up, settle into your seats, and head out into space with your tour guide, Molly Bentley. Molly, take it away.
Thanks, Bill. Okay, I'll make my remarks brief so we can get right to our speakers. Happy anniversary, Hubble Space Telescope, 30 years young. We are here to talk about the legacy of the world's most famous telescope, so called because it fundamentally changed our understanding of the cosmos. And we will hear about a next generation telescope, the newly named Nancy Grace Roman Space Telescope. It is set to launch in the mid-2020s. We'll hear what we can expect from it. Both our guests have contributed to Hubble's scientific and technological endeavor. So let me introduce the guests. I'll do them one at a time. I'll introduce them one at a time. And after I introduce them, they will say a few words and then we'll launch into our discussion. Now, we've all become aware of needing our space these days. but John Grunsfeld has been thinking about space for most of his life. He's a former astronaut veteran of 5 space shuttle flights, maybe flights too. Maybe he'll tell us about those. I'm sure it gets pretty tense up there in the space shuttle. A physicist with an expertise in astrophysics and exoplanets, Dr. Grunsfeld is known as the Hubble repairman for performing 3, if not 4, but I believe it's 3 of the last 5 Hubble servicing missions, the last one being in 2009. He was introduced or inducted in the U.S. Astronaut Hall of Fame in 2015. I need oxygen for these introductions. He has served as NASA chief scientist, which means that he was the principal advisor to the NASA administrator. And he is the only astronaut to have climbed to the top of Denali in Alaska, which we can only imagine he did because it brought him a little closer to space. Welcome, John Grunsfeld.
Thank you very much. Really a pleasure to be here. This is my first SETI Institute symposium. So my vote went to yes, online only. It's great to see a lot of new folks online for this talk, and welcome. And my job tonight is in about 4 minutes to summarize 30 years of history of the Hubble Space Telescope. And I'm going to take over the screen and get started with that. But along those lines, I think it's, a great testament to, the wonderful people of NASA, the technicians, the engineers, the scientists, NASA contractors, and in particular, Nancy Grace Roman, who shepherded the Hubble Space Telescope program through its launch and commissioning. Otherwise, we wouldn't have a Hubble today. And so Meg is going to talk a little more about the next telescope, the Nancy Grace Roman telescope, and I'll cover Hubble. Hubble has been on orbit 30 years, and it's really just a phenomenal feat that Hubble has been able to keep operating for all of those years, and a testament to NASA's technology. But it didn't start really with Hubble. It started with Galileo, and Galileo turned a telescope not to spy on his neighbors as it was designed, but to look to the heavens. And the discoveries he made helped start a scientific revolution, a renaissance in our knowledge about the universe. The things he discovered, have a universality that was really incredible. And we're not going to talk about how he was persecuted, but on Space Shuttle Atlantis, we were able to take a replica of his telescope. And you can see it there in the picture. And in the background is the Hubble Space Telescope. And only a few hundred years separate those, which is pretty amazing, the amount of technological advances that we made to be able to get a Hubble Space Telescope. Now, Hubble has been able to spend 30 years on orbit and be a state-of-the-art telescope with modern instruments and detectors and cameras that are still, up to snuff today, because we were able to do 5 space shuttle missions. In fact, Hubble was designed to be serviced by people from the space shuttle. And the idea is each time we went up, we were able to improve the optics, put in new scientific instruments, cameras, and repair little things that went wrong, electronics, power systems, put on new solar arrays, fix computers, all the kind of things you would do on a telescope on the ground, but of course in big bulky spacesuits. And one of the reasons I went to climb in Alaska in Denali is because it's really cold and you have to wear big bulky jackets and a big backpack. Well, the ultimate adventure, the ultimate expedition is to go into space and do a spacewalk. And this is a picture of me out in the payload bay of the space shuttle, wearing one of those spacesuits. Outside is a vacuum. I've known Meg Urey for many, many years. And I think probably a long time ago, she asked, John, do you work in a vacuum? And in fact, I do work in a vacuum. And that's what the spacesuit is for, is to protect the nice environment that we have here on Earth inside of that little spaceship, a spacesuit. And the other thing you'll notice is in my visor is reflected planet Earth. And you can see on my face a big grin. And almost all the time in space, I had that big grin. It's totally magical. But our task was to upgrade and repair the Hubble Space Telescope, extend its life, and help us to unravel the mysteries of the universe. And so here's a picture of myself and my spacewalking partner, Drew Feustel, on the outside of the Hubble Space Telescope, putting in Wide Field Camera 3. That's the super duper digital camera that allows us to take those really beautiful images of Hubble. After 5 spacewalking days, I did 3 spacewalks on that mission in 2009. We deployed the Hubble Space Telescope, and this is the last view that I had of Hubble and our crew, and so far any other humans, as it went off to do its mission of astronomy. The Hubble Space Telescope is about the size of a school bus. It's not a particularly large telescope, but because it's above planet Earth, it's able to make all these amazing discoveries. And this is one example of one of those Hubble images, which is the Great Nebula in the constellation Orion. If you look at the constellation Orion, the middle star of Orion's sword is actually this nebula. And what it shows us is not only has Hubble helped us understand how stars form, how black holes are in the center of almost every galaxy. That's what Meg studies, and cosmology and the history of the universe. It's also shown us that the universe is much more beautiful than we ever imagined. Hubble is able to take pictures of these celestial objects with the same resolution that we have with our eyes. And so it's given us a human view of how beautiful the universe is. And what about the future of Hubble? We don't know how long Hubble will last, but we're developing a lot of new capability, SpaceX capsules, Blue Origin rockets, the Orion capsule and the Space Launch System. And who knows, maybe we can send one of those vehicles back to give Hubble another 30 years of lifetime. So with that, I will hand it over to Meg, but I just want to point out that even though Hubble has been on orbit for 30 years and we're building new telescopes, the James Webb Space Telescope, the Nancy Grace Roman Telescope, that the Hubble story is still very much alive. And I predict that the greatest discovery that Hubble will ever make is still on the horizon. So with that, I will hand the screen back.
Okay, Molly, are you muted?
I am muted. Okay, here we go. I said, thanks, John. Now, Meg Urey is the director of the Yale Center for Astronomy and Astrophysics. She was chair of the Department of Physics, president of the American Astronomical Society, and was a senior astronomer at the Space Telescope Institute, which runs the Hubble Space Telescope. She studies the growth of supermassive black holes to understand how they evolve with galaxies. She has been devoted to making science accessible and inclusive for women, something that she shares with Nancy Roman. Dr. Urey co-organized the first meeting of women in astronomy in 1992. Welcome, Meg Urey.
Thank you so much, Molly. And just to say, I was at the launch, not the launch, but I was watching the launch of Hubble many years ago, 30 years ago, and my first daughter was born during the first servicing mission. So I stayed up all night watching those astronauts out there doing those amazing things. And thank you to you guys for that. All right,
You watched it while you were giving birth?
No, I wasn't quite that advanced, but I was up all night for several nights. So,
Oh my goodness.
I was there. Have you got my screen? Can you see the images? Okay, great. I'll just say a few words about some of the amazing science that Hubble has done. And this is my favorite. This is one of the Hubble deep fields. Many times Hubble pointed at a dark place of the sky and exposed the camera for 10, 12, 14 days at a time. And this is what resulted. This image shows thousands and thousands of galaxies. In all, we've cataloged hundreds of thousands of galaxies in these surveys. And everything you're looking at pretty much is a galaxy, these fuzzy objects. Some of them are very big and luminous, like the one in the lower, this very bright galaxy in the lower part of the image is clearly a spiral galaxy, not too different from our own Milky Way. Some of them are round, like this yellowish, reddish galaxy with older stars. Some of them are bright white galaxies that have new stars forming. Every galaxy is different, and these kinds of images allow us to understand how these galaxies form and evolve over the entire history of the universe. We can see back about 13 billion years where the age of the universe is 13.7 billion years. So most of the way to the beginning of the universe. Now, one of the things that happens as these galaxies are evolving is that they collide with other galaxies and acquire new shapes. So I'm going to show you a computer simulation. It's a movie of a calculation in a computer of the gravity between two sort of equal mass spiral disks. And every so often this movie pauses and shows you a real image that shows a pair of galaxies in the process of interacting gravitationally. So you'll see the computer simulation. These galaxies are pulling on the other galaxy. And we call these forces tidal forces because the near sides of the galaxies pull harder on each other than the far sides. And that creates a sort of a wild flinging out of stars into intergalactic space, forming these huge tidal tails, which are a direct sign of gravitational interaction. I should explain, we don't get to see this interaction happen because the total time for this thing is about 300 million years. So we only see the snapshot of a particular stage of the interaction. But in this way, galaxies evolve in their mass and their shape. And the Hubble images and other images allow us to see things like this. We call them train wrecks, where galaxies are colliding and forming a new, more massive galaxy. And by the way, the black holes at their centers sink to the middle and eventually merge as well. So an image like this you now recognize is a pair of galaxies in the process of merging. And those huge tidal tails are the sign of that. If they didn't have that, they might just be a superposition of galaxies that are not close to each other. I'll show you one more picture. These are all Hubble images. This is the Sombrero galaxy. This is a galaxy that has merged many times in the past because that gives it this big round glow of stars, many stars in a sort of round shape. But the fact that there's a very prominent disk means it didn't have a big merger recently. Otherwise, that would have destroyed the disk. So those are just a few examples of how we can learn from images how galaxies evolve over time. So what's next for space astronomy has already been alluded to. I want to mention the James Webb Space Telescope, which is the Hubble successor that's going to launch in a little over a year. It's a much bigger telescope. It's a segmented mirror that has about 10 times the collecting power of Hubble and has been optimized in the infrared. But coming up just after that is the telescope you heard about a moment ago, the Wide Field Infrared Space Telescope. Everything's an acronym. It's a Hubble-sized telescope, but with a much wider field of view so that it can do a sky survey like Hubble, but many, many times bigger. And as John and Molly said, this telescope was recently named after the wonderful Nancy Grace Roman, who was NASA's first chief scientist and is often referred to as the mother of Hubble. She's the person who really made Hubble happen, who pushed for it, who made sure it was scientifically productive. And it's a wonderful way to honor her and to look forward to what this amazing telescope will do starting probably at the end of this decade. Back to you, Molly.
It's lovely.
Unshare myself.
Unshare yourself. Okay, now we're going to talk to Meg Urey and John Grunsfeld and invite the audience to submit questions. And you can do that if you're not familiar with Zoom by just clicking on that Q&A icon at the bottom of your Zoom page. So please let your questions roll in, and at the end of our discussion with the scientists, we will ask your questions. Meg, let's start with you and an overview of what made Hubble special. Now, if we were to go out and look at the night sky, we would see thousands of points of light, tens of thousands, or whatever it may be that we could actually see. What technology allowed Hubble to zero in on one of those dots and reveal an entirely new world? Does it simply come down to magnification power?
it isn't just the power of the telescope and the detectors, because on the ground we have some great telescopes and detectors. But if you noticed when John showed you that last picture of Hubble as it was leaving the space shuttle, the Earth was covered in clouds. And that atmosphere prevents, not only, I mean, if it's cloudy, you can't observe, but even when it's clear, the atmosphere blurs the images by about a factor of 10 compared to Hubble. So the Hubble images are 10 times sharper than a typical image from a ground-based telescope. And I think that's one of the big advantages. Another is that the sky is dark. So there are no lights of Phoenix or Tucson or Hilo or Kona bothering, competing, making your telescope image noisier. So those are two huge advantages of space that simply can't be matched on the ground.
I have a question for John. I don't know if he's still with us. I don't see his
Yep,
image
he's there.
there.
He's there.
He
Yep.
is. Okay.
I can see him.
Okay, I don't see it on my screen, but that's okay. I'm used to radio. I don't see my audience at all. Now, John, Hubble is considered the model of excellence. You have the Hubble of cars, I don't know, the Hubble of microscopes, but it wasn't always so. After the telescope went up in 1990, NASA discovered that the mirror had not been grounded properly, and the agency became the butt of a lot of jokes, even on late night television. I think Johnny Carson made some jokes. What happened next?
Well, in fact, that's exactly right. The telescope was produced and launched with a mirror that was probably the most precisely ground mirror ever made, except it was the wrong shape. And so Meg probably remembers this, but when the first images came out, there was a lot of head scratching. Like, we thought this was going to be a great observatory, and it's not really even a good observatory. And pretty quickly, the astronomers and the engineers realized by looking at the images of stars that instead of being those sharp points that Meg said Hubble is so good at seeing, points of light, the light was spread out. And it's due to the fact that even though the mirror was ground very precisely, it was the wrong shape and it had spherical aberration. And fortunately, by observing those stars and measuring the shape of the stars, how much it was blurry, engineers could figure out what the shape is on orbit. And so they could figure out, how do we fix it? Senator Mikulski, who was senator from Maryland, who was very supportive of the project, basically said in 1993, in the space shuttle, we sent up new instruments with contact lenses. Actually, they were mirrors, and those mirrors had just the right shape to correct the mirror on Hubble back to the original specification.
So basically it was serviced. You were able to go up to Hubble, the engineers were, and to fix the telescope. And it wasn't the first time that this would happen. And we'll come to the other servicing missions in a moment. But, I started by saying that NASA was the butt of jokes, but really Hubble got the last laugh with this, because not only did the servicing mission fix it the way that you described, the spacecraft returned these images of unimaginable beauty and detail. And we saw some of those images. For the two of you, I wonder if you could just give us an overview, if you wouldn't mind, because there are a lot of other questions, but the overview of the big discoveries of Hubble. I know you mentioned some of them, but if we could put them together, John, what are the couple of the big ones in your book?
Sure. Well, exactly what you said. Hubble, the brilliance of Hubble is it was designed to be fixed by space shuttle astronauts. And so that first mission was able to restore the vision and let Hubble go and achieve, what it was planned to do. And so what it was planned to do was to measure the cosmic distance scale, which is essentially measuring, the age of the universe, how fast it's expanding, from which we can figure out the age. And the thought was maybe Hubble can see halfway back to the Big Bang when the universe was created. And at that time, it was thought maybe 10 to 12 billion years, based on ground-based observations. It was also designed to look at a lot of other galaxies and figure out how galaxies evolve, how the gas and dust inside galaxies interact with the stars, to create new stars, star forming. Behind Meg is a picture of a star forming region, and understand how the universe works. It was also designed to look at supernovae and to look at the origin evolution of our solar system, looking at Jupiter, looking at Uranus, Neptune, even diminutive Pluto. When Hubble launched, Pluto was still a planet. And then also to study black holes and kind of prove whether they exist or not. Do we really know there are black holes? So that's what the original goals were.
And then
but it turns out Hubble has done so much more.
Yeah, let me get that list. Let's have Meg add to that list, but we have galaxy formation, the age of the universe, black holes. Meg, do you want to add to that?
Well, I was going to say, I mean, John set this up perfectly, that Hubble's, some of its greatest discoveries perhaps are things that weren't even known before Hubble was designed or launched. So for example, exoplanets, the planets around stars other than our sun, were not discovered until after Hubble was launched. And yet it turned out to be a great instrument for measuring the constituents in their atmospheres. Very clever observations to see what those exoplanets are made of. Another example is dark energy. A very nice experiment that was being done at the end of the 1990s discovered that the expanding universe is actually, the expansion is accelerating. The experiment had been designed to measure the rate at which it was decelerating due to gravity. And instead they found it's accelerating due to something dubbed dark energy, some new kind of energy or force field that was not even known when Hubble was launched. So I think those are also really important discoveries, and the ability of astronauts to add new instruments made it possible to study things that at the time of the design of the telescope in the 1970s, wouldn't have been technically possible at all.
Well, Meg, I commend you on describing dark energy without using the adjective weird. I don't think I've ever heard it described without being described as that weird stuff. And just to emphasize how big a discovery that was at the end of the 90s. As you said, Hubble astronomers and cosmologists thought one thing about the universe, thought that it was contracting. And not only did they find out that it was accelerating, that it was expanding, but that it was accelerating. And that really changed science. So that was a big story at the end of about 1998, I think it was.
Yeah.
Go ahead, John.
Noting that there was a tantalizing evidence in 1998 of this, but it could have been instrumental. It could have been dust in galaxies and lots of things. And it was really Hubble with the new instruments, the advanced camera for surveys, that allowed us to confirm that. And two things. One, we shouldn't leave out that Saul Perlmutter and Brian Schmidt and Adam Rees won the Nobel Prize in 2011 for this discovery, where Adam said, "No Hubble, no Nobel." But what's really interesting is that Einstein, when he wrote the basic equations that describe space and time, had a term in his equation that might be related to this acceleration. And for years and years, physicists have called it his greatest blunder. And of course, here we are now in 2020, and we're using that theory with that term that he put in there and was called his blunder to try and explain dark energy.
Was that the cosmological constant?
The cosmological constant. It's a fascinating story that really shows how clever human beings are to be able to, why should we expect to be able to write mathematics that explains the behavior of the universe?
Now be fair, John, be fair. Einstein put that in there because he stupidly paid attention to theorists who told him that the universe could not be expanding or contracting. And he knew that it should be contracting because of gravity, right? Gravity is an active thing. They told him it was steady. So he put in this fake force to push out to opposite to gravity. So it was a crazy idea, I have to say. And it turned out to be correct, or some approximating reality.
Now for the audience, I think the most important,
go ahead.
To know, though, is that this little, and I will use the word weird, this weird acceleration that nobody expected actually is responsible for over 70% of the entire energy content of the universe. And we have absolutely no idea what it is.
This is a good time for the poll. We have an audience poll that has to do with what the audience members would vote as their favorite Hubble discovery. And I think Lee is going to put that up in a moment. And for the people, audience members who are on Zoom, I think you can see it right there. What is your favorite Hubble discovery? Oh goodness, talk about corrective lenses. John, I'll just have to do this myself. Cosmology, age of the universe, measurement of expansion rate, discovery of dark energy. Okay, that one's pretty heavily packed. That one's pretty packed to win, but there's a lot in that one. Or the atmospheres of exoplanets, measurement of what they're made out of. That's lovely. And lastly, Hubble deep fields, evolution of galaxies, and supermassive black holes. So audience members can choose one of those. I think it's a winner no matter what you choose. Let's move on to the Orion Nebula, because I think one of the lasting legacies of Hubble, and I shouldn't use Hubble in the past tense, because as John said, we want to keep Hubble going. Maybe it'll be like Spirit and Opportunity that just continue long past their expected date. But the Orion Nebula, the colors, and I believe the colors are, the Orion Nebula is behind Meg right now.
This is the Carina Nebula, but it's exactly
Carina,
the same kind of thing.
Okay, but it'll illustrate those colors in the nebula, the oranges, the pinks, the light blues, and the grays. Some of the colors are there behind Meg too in that nebula. What are the what accounts for those colors? Is that a colorized image, or is that actually what Hubble saw?
It's approximately what Hubble saw. You know, Hubble doesn't have eyes, and so it doesn't have rods and cones like we do. So it's a little bit, it's a combined from multicolor images, but these are real wavelengths of light that are, they're young stars that are making very, very bright UV light, ultraviolet light, and that ionizes the gas around the star and excites the atoms, and they then emit line emission. And that a lot of what you're seeing is atoms of hydrogen, oxygen, carbon, etc., shining at particular wavelengths. So when those wavelengths are combined, you get these amazing, incredible pictures that just, you know, you could stare at for hours.
You know, this brings me to the next question, because when you look at that, I mean, if you were going to picture what does a star factory look like, you couldn't picture anything more beautiful that lived up to the name than that image of the Orion Nebula. And I know that these images are very important for cosmologists and astronomers, but what was the effect of seeing those publics? What effect did seeing those photos have on the public? John, do you want to answer that?
Certainly. You know, I think it's, you know, that's, as I mentioned it, you know, in the introduction, one of the things that Hubble has contributed the most to is that it's given us that view that the universe is much more beautiful, rich, and deep than we ever imagined, because it does appeal to humans as a very visual experience. And not only, you know, people, you know, with normal vision, but we've actually created equivalent images for people who are vision impaired, that have texture. And so they can share in that too. But these beautiful views of the universe have made Hubble kind of an icon for science, for scientific discovery. And I think that's one of its contributions. And so the deep field, you know, inspires an imagination about the vastness of the universe. The Carina Nebula or the Orion Nebula, you know, you learn that it's a star factory where baby stars are born. But you look at it and it's as beautiful as any kind of, you know, abstract art that a human would create. And as a result, and the ability to download all of the Hubble images off of a website, hubblesite.org, makes Hubble the people's telescope. You know, it's not just for astronomers. Anybody can get access to the data and download the data and look at the images. And I think that's what, and its longevity, after 30 years, it's taken a lot of pictures. No, that's one of the things that I think we can say it's been successful at providing to, you know, to everyone this front row seat to the universe. When
those photos are taken, does Hubble take a photo? Is it this is a really basic question if you're ready for it, but does it take one snap and that's it? Or does it return to the same spot over and over? And as actually what we're seeing is a number of photos in a kind of, you know, amalgamation or something, or it takes, you have to take a few shots in order to get a good photo.
Yeah.
Well, Meg kind of described that.
Yeah.
But, you know, I have my cell phone here, and if I take a picture of Meg with my cell phone actually takes 3 pictures at once. It takes a picture of Meg in red, green, and blue, and a computer inside of the phone puts those 3 pictures together. To make the picture behind Meg, Hubble actually took 3 individual pictures, one after another, through colored filters. And that's what she described. One colored filter is in the color that hydrogen light emits. Another one is in a filter, colored filter, that's specific to oxygen light, and another one to nitrogen. And in fact, I think in the picture behind her, there's a 4th one that's sodium. But each atom, as it vibrates, puts out a specific light, and Hubble takes sequential pictures one after another, and then we mash them on top of each other, just like the computer in your phone. And for an astronomer, and I'll hand it over to Meg, you know, using that information tells us about the physical conditions in that nebula. And then somebody puts them together to make a beautiful picture like that. So we would see it as if, you know, we're looking at it. You know, astronomers tend to use the individual images, not the combined one.
I'm going to move on. I know that Meg will probably have more to say about Orion, but I do want her to talk about more about the Hubble deep field photo. But first, one other question about servicing. Now, John, you did three servicing missions, right? Yeah. Yep. Okay. Now, if we do repairs around the house, you know, if I'm repairing a light bulb, you know, replacing a light bulb or something, I don't have to worry so much that if I make a mistake, it might cost me my life. What is it like to do a repair or to work at all in the dangers of space, the way that you have?
Well, you know, we're in that pressurized spacesuit, and outside is a deadly vacuum, and the spacesuit is made out of cloth. So there is an element that you have to think about, be very careful. And we do lots of tests to make sure that on the space shuttle, there are no sharp edges.
Did you just say that your advice is be very careful?
Yeah, pretty much.
Okay, we got it. Okay, be very careful. All right.
And we actually, you know, do lots of things like periodically every hour, you know, we look at our gloves to make sure they're not cut. It doesn't take a very big hole so that all the oxygen would leak out and you would die. And, you know, there are some sort of common wisdom, like don't use your hand as a hammer, you know, if you have to push on something, because, well, you could pop your glove and that would be the end of you. But, you know, the other side of it is that we had a rule. This was my rule. It was not the first rule. The first rule is be safe. Don't do something dumb. The second rule is don't break the Hubble. You know, this is a, you know, multi-billion-dollar international resource. And, you know, when I gave talks after the missions, I would say, you know, we didn't want to break the Hubble. And, you know, I didn't, because if I did, I would be exiled in Bolivia, you know, not coming and talking to astronomers. And Hubble, even though it was designed to be fixed by spacewalking astronauts, is pretty fragile. It's still a telescope. It's still a spacecraft. Mm-hmm. And easy to break. So we had to be very careful, not only not to hurt ourselves, but not to hurt the Hubble either.
Mm-hmm. And Meg, and just as an aside, and I believe the Roman Space Telescope has been created so that it will be amenable to repairs as well, because we've learned so much about the effect of repairing, how it can extend the life of a telescope. Meg, you reviewed for the journal Nature, I think, astronaut Kathy Sullivan's book on, it was called Handprints on Hubble, and it was about servicing the telescope. And I think what struck you about these repairs is the level of detail that's involved. Can you just say briefly say something about that, and then we'll talk about the deep field photo?
It was a wonderful book. I learned a lot. You know, you don't just go up there with the toolbox from the Craftsman tools from Sears. You know, every single tool used for a particular, to do something to this particular screw in that particular instrument was designed, custom designed and tested and refined and tested and refined again. They did a huge amount of, many hundreds of hours of mock repairs in diving suits in a swimsuit tank, in a swimming pool. And it's remarkable. And I have to say, I mean, my hat is off permanently to John and his colleagues who, they didn't just repair a telescope designed to be repaired. They took out instruments that were never designed to be repaired. They took out screws that were never designed to be done. And they did it in many, many times the number of hours that any flight crew supervisor was going to ever allow. I mean, they pulled off miracle after miracle there in space. But the payoff is what John says. You have this amazing telescope that can do amazing things. One of the new cameras they put in has a CCD detector, a charge coupled device. That's what's in your phone. I thought that was the point John was going to make when he held up his phone. It's a very sensitive detector. These things did not exist in the 1970s when Hubble was first designed. So the power is also, the technology moves along, and the telescope has evolved and is basically a modern telescope today.
Now, by the way, no offense, John, that I compared it to changing a light bulb. I think that's the only thing I've really repaired in my house. So that was the only analogy I could go with, but I do understand it's a little bit more complicated than that. Meg, let's talk about the Hubble Deep Field photo. So when that photo was taken, and I know you said some words about it, and perhaps I'll be just asking you to repeat yourself, but I think people are very interested in this photo. And by the way, if you have questions, anyone following this, you can write the questions down there at the bottom of your Zoom. Q&A will do the questions soon. The photo was taken in 1995. And it's my understanding that it was of an area, if seen from Earth, that was no bigger than the head of a pin held at arm's length. So if you went like that, you had a pin in your hand. That's the area of the Hubble Deep Field photo. And yet, what resulted changed astronomy. Can you give us an overview again of why this photo was so important?
Yes. First of all, it couldn't have been done with any other telescope. It couldn't have been done from the ground because of the sharpness of the telescope and the ability to basically keep the shutter open for 10 days. That was the first. So as the telescope was orbiting the Earth, which it does every 90 minutes, it just kept exposing the camera for that for days and days and days. I think also there was a tremendous community coalescence around these data because the director of the Space Telescope Science Institute made the data immediately public so that every astronomer in the world had access to it and could study it. There were people running to telescopes on the ground to look at particular galaxies to measure their distance. And so very quickly, a lot of science just built up in the community of thousands of astronomers around the world.
So in that way, it not only changed astronomy, but it changed the culture of astronomy.
It did, really. It had a huge impact. And I have to say, it isn't the only survey ever done. After that original Hubble Deep Field, there were other additional surveys, deeper, larger, with the new camera that wasn't on the telescope in 1995 and so on. And each of these, one of the recent deep fields led to the discovery of the most distant galaxy ever, a galaxy that's at redshift 11, if for the cognoscenti in the audience, but basically it's formed a few 100 million years after the Big Bang.
I call that a galaxy far, far away.
We have to name these. We have the deep field, we have the ultra deep field, we have the extreme deep field. And maybe Maggie, you can make a couple of comments that this deep field imagery has been so powerful that that's why we built the Nancy Grace, or are building the Nancy Grace Roman telescope, is to do lots of those, to not only look deep into the universe, but to start looking at the spatial distribution across very large scales and the shapes of the galaxies themselves.
Yes, this pin at the end of an arm the Hubble has a fairly small field of view. The camera is fairly small, and if you could tile the whole focal plane with a much larger camera, you could do 100 times the science in the same amount of time. And that's effectively what WFIRST, sorry, I got to get used to calling it Roman. It's very new that it's gotten named Roman. The Roman telescope will do.
Let's say more about the Roman telescope in a moment. One other follow-up on the deep field photo, just to give people an idea of what this photo was able to show. And it was really showing a history of the universe, of galaxies, with the newest objects closest. And I read that the way to think of this, and this is a problem with analogies, but is that if you had a telescope pointed at Earth and you could look at Earth's history, you could see the pyramids in the front, you would see a Neanderthal family behind that, and in the back and behind the Neanderthals, a dinosaur. So you could just see all of Earth's history in one continual shot. Is that in the ballpark of what the Hubble Deep Field did?
Yeah,
in
yes.
Precision?
I would say it's not, let me leave your analogy out of it. It's important to say that in astronomy, because we're looking to such large distances, the light takes an appreciable amount of time to reach us. So if I'm looking at a galaxy that is 1 billion light years away, the light I see today was emitted 1 billion years ago. And if I see a more distant galaxy, one that's 10 billion light years away, I'm seeing its light as it was 10 billion years ago. So we're like archaeologists, I would say. We're digging the farther away we look, the younger the universe is. We're seeing, it's like we're seeing every stage, but just by looking farther away. And you know, that field has also a lot of power because we combine it with other space telescopes. We combine it with the Chandra X-ray Observatory and the European Newton XMM mission and the Spitzer Infrared Telescope. And the power of combining these multi-wavelength data help us decipher what each galaxy is made of, how much mass it has, how whether its central black hole is growing, etc.
It's incredible.
Whether it's colliding with another galaxy.
Whether it's colliding with another galaxy, yeah.
Now, I'd like to ask a question about Nancy Grace Roman and about the telescope named after her. We could talk, there's so many more questions, so I have to apologize for that, but then I do want to turn it over to the listeners and viewers. I'm so used to saying listeners in radio, but I guess in this case it's viewers too, audience. But the astronomer Nancy Roman occupies a spot tonight that bridges the past and the future. As Meg said, she was the mother of Hubble. She spearheaded the development of the Hubble Space Telescope. And I wonder, John, if you could tell us why she was so determined, very briefly, because then we want to get onto the instrument, but the new instrument, why she was determined to see this telescope launched. Like, what was her vision? And then what was her role? Was it conceiving of the technology, or was it convincing other astronomers in Congress that this was an important instrument?
Well, I think it's a combination of all of the above. You know, the first thing to mention is that Nancy Grace Roman was an astronomer. And she was an astronomer at a time, you know, 1960s, 1970s, when very few women went into astronomy. You know, it was not, I don't know what it was like for Meg when she first decided to go into astronomy, whether her parents or her peers told her she was crazy. Or not, but I can tell you she was not crazy. But Nancy Grace Roman, who was born in 1925, this was something that women supported, but not something they led or became professors or became professional astronomers. But
if I could just insert, in fact, she majored in physics against the advice of her professors. She was not encouraged to do what she did.
And there's a lot of history about women who tried to go into astronomy and were discouraged and never ended up getting faculty positions or, went off to other fields. And it's a real shame. But Nancy was, by any measure, incredibly persistent. And she was also the first woman executive at NASA. If you think about the 1960s pictures, movies of NASA, documentaries, what do you see? You see a lot of 30 and 40-year-old white males in white shirts with ties,
Yep.
Smoking cigarettes and cigars. But Nancy was there. And I just think it's the strength of her personality that allowed her to become a successful astronomer, and then to be the first female executive at NASA, then to be the chief of astronomy in the science directorate during the 70s and 80s, or 60s and 70s, leading up to the Hubble Space Telescope, and then for her essentially in that role to become the mother of the Hubble Space Telescope and push it through. And I think it's because she worked with other astronomers, people like Lyman Spitzer and John Bacall and others, who recognized that putting a telescope in space would be so powerful that it would change the world. And she certainly did change the world.
Well, speaking of FIRST, and we're going to talk about the WFIRST, and then we'll get to the questions. I just should have mentioned, because as you outlined Nancy Roman's history, I mean, some of it has echoes to Meg's. I mean, it gives you an idea of how things haven't really changed, if you don't mind my saying, Meg. I mean, Meg was the only woman at the Yale physics department when she arrived. She was the first female tenured professor. Both she and Nancy Roman have worked for, and Meg continues to work for, gender equality in science. So the way things are changing, but they have also been stubbornly changing. And I just wanted to say that about those parallels, if Meg doesn't mind my doing that. Very quickly, and then let's take the questions. And Rebecca, if you're ready there in the Zoomverse, we will get these questions from the audience. Hubble at age 30, seems very young, has shown incredible productivity. And so now we're going to talk about the Roman Space Telescope. It's a successor of a space telescope that was spearheaded by its namesake. Meg, what can we expect from the Roman telescope, and can it do for Hubble? Can it do for astronomy what Hubble did? I mean, it has very big shoes. Okay, if not shoes, it has very big solar arrays to fill. Meg, can it fill those solar arrays? Give us a couple highlights.
So I would say it's the two purposes for which it was designed originally are to study these two things that didn't exist when Hubble was designed, namely exoplanets and dark energy. And in particular, dark energy, one of the ideas, there are two main probes. They'll look for distant supernovae. These are exploding stars, massive stars that explode at the end. They don't have to be that massive, but they explode at the end of their evolution, at the end of their lives. And those flashes of light are little signposts that allow us to find the distance to that signpost and therefore measure the expansion history of the universe. We can see how big the universe at each position of each supernova. And to find them, you need to look over vast regions of space. And that's why this wide field imaging, survey camera is so important. The other thing is there are some experiments you can do with exoplanets, in particular with transits or microlensing of exoplanets, and Roman will do that as well. But just like Hubble, I expect its greatest discoveries will be things we don't know about yet. That's one of the amazing things about astronomy. It's a discovery science, and the laboratory is out there. You haven't designed the laboratory, nature designed it. And so what we find will amaze us.
I love that. Okay, let's take some questions from the audience, and I think they've really been piling up. Okay, Rebecca, what are the questions? There seem to be a lot of them.
There are a lot of them. So one question from Dave is, why does it take so long to develop new space telescopes?
I don't know who you want to take a stab at that. I think part of it is they're very complicated, big, expensive machines. So some of the time is in the design and the manufacture, and some of the time is in getting the funding to build them.
But Dave, I think Dave was the person who asked the question. Also, in the scheme of the cosmic time, they're actually put together pretty quickly, aren't they?
Well, cosmic time, certainly, but it's not that much different now building a large ground-based telescope. We're trying to build two new telescopes that the United States is the principal on, and the Europeans are building their own. And it takes, more than a decade just to get the funding, as Meg said, from, public funding sources and private funding sources. And then it takes a decade to design and prototype all of the systems, and then another 5 years at least to build the instruments, the cameras, and then check it all out. And so in a sense, the big ground-based telescopes, or the Hubbles, or the Roman telescopes, are kind of our modern day pyramids. Different purposes, of course, but they're our legacy to large, complex engineering projects.
Yeah, it's not that different from building a Boeing airliner from scratch.
Let's pause for a moment to put up the results of the poll to find out how people responded to what they thought the favorite discovery of Hubble was. Let's see. Okay, here we go. Put on my corrective lenses. Oh, can you read it, Meg? Do you want to?
Yeah. So cosmology is winning there by an edge, and Hubble deep fields are close behind. And atmospheres of exoplanets, probably because we didn't get to talk about it enough, is third. But they're all pretty exciting. So I think everybody's a winner.
Yeah, it looks like cosmology, dark energy, as she said. Hubble deep field came in a second, and atmosphere of exoplanets. But as she said, if we talk more, it's really hard to choose. Just as an aside, John, you just mentioned the Europeans, but technically, wasn't Hubble launched by ESA as well, by the European Space Agency? They have a role in this. It's not just a NASA project, right?
So almost all of our projects at NASA in science are international projects. We have lots and lots of collaboration around the world. And for Hubble, if you try and look at by cost, for instance, about 15% of the Hubble Space Telescope was contributed by ESA, so European Space Agency. The original solar arrays were provided by European Space Agency, as was one of the instruments. And over the years, we've continued that collaboration. And what's interesting is, I said Hubble is the people's telescope, but it's also, astronomers' telescopes around the world. Astronomers propose observations, and it doesn't matter where they come from. And so even though the Europeans only contributed 15% of the project, they typically win about 30% of the time. But even there, almost all of the investigations are collaborations. I'm sure that Meg has international collaborators on her project as well.
Let's move on to another question, but it's nice to just be reminded of that international collaboration these days. Okay, Rebecca.
Okay, this is a question from Liza. It's not directed at anyone in particular, so either one of you could jump in. But the question is, how do space telescopes fare with space dust and other obstacles, debris like meteorites?
I'll grab that one. Meg, you can have the next one. It's a great question because there is space debris up there. At Hubble's orbit, most of the debris is from other spacecraft that have shed little bits, flecks of paint or broken bits. And because I went up to Hubble 3 times and saw Hubble, right up in front of me, it was interesting because between flights, I was able to see places where I'd been before that were clear. And then there's some little crater where the aluminum on a handrail had been blown off by something hitting the Hubble. The good news is, because we observe stars with Hubble, I mean, that's its job, and some stars we observe over and over again, we're actually able to measure how much stuff has hit the mirror. And the mirror is in still great shape. It really hasn't taken any big hits. I will say that you can see right there, whoops, my finger's disappearing. Right there is one of the comm antennas, the communication antennas. And when I got up there in my first mission, there was a hole about the size of a quarter in that antenna where something big went through it. And I was out doing a spacewalk and I thought, boy, I hope whatever made that hole doesn't hit me.
And John, when Bill said that you were the last to touch Hubble, literally, you were the last person to put a hand on the spacecraft, right? On the telescope.
Yep, or as Kathy Sullivan would say, put my handprint on Hubble.
Okay, another question.
Okay, this is a question for Meg, and it comes from Andrew. He says, Meg has been a pioneer in examining the complex role of women in astronomy and helping the community make sure women have more opportunities. How do you think the struggle is going these days?
Well, it's been, I mean, things have really changed a great deal. women are now getting a third or more of the PhDs in astronomy, compared to 15%, 20, 30 years ago. And I also think our community is more aware of the obstacles that face women. When I was young, people told me I would have every advantage being a woman because of affirmative action or whatever. And I think we've all been experiencing this in our communities in the last few months. The conversations around Black Lives Matter and these kinds of things, which are a belated awakening to the fact that there is not equal opportunity for everybody. But I think also an awakening to the fact that we need to tap everybody's talent and use all the talent that's out there and not restrict fields to a very small subset of that talent. So I would say it's very promising, and we haven't finished, we haven't finished the job yet.
Will you let us know when the job's finished?
Well, it's easy. It's easy, particularly for women. When half of astronomers are women, when half of Supreme Court justices are women, when half of the federal government is women, then we'll know we don't have a gender bias. And I should say gender is not binary, so I'm approximating, but you see my point.
Yes. All right, another question.
Another question. This one comes from Anne. Will Hubble be kept in operation after James Webb is deployed, and will it ever come back to Earth?
John, you want that one? Yeah.
Yep. So we hope that Hubble and James Webb will have a long overlap because they do different things. And the power of Hubble, which has detectors that are sensitive to the kind of light that we see with our eyes, and James Webb Space Telescope that sees in the infrared that we don't see, and that's why we built James Webb to look at the universe in the infrared. Those two together, and ground-based telescopes and radio telescopes all working together, is where the real power of discovery lies. And that's our plan, is to keep Hubble going as long as possible, as long as it keeps working, to work in concert with these other observatories. An example is the Roman telescope is a very wide field telescope, and it's going to see things that pique our curiosity, and we'll want to turn Hubble with the narrow field of view and study that object to find out what's going on. Now, as far as bringing Hubble back, that would be very difficult. You'd need something like the space shuttle, and even then you would have to do a bunch of spacewalks to take things off of Hubble. And if we're going to go to the trouble of going up to Hubble with something to try and bring it back, why not service it again so that it can stay up longer and do great science? So I don't think Hubble will ever come back to Earth.
But it's not like
not planned, but at the end of its life, 2035 or somewhere in the 2030s, atmospheric drag will have caused it to spiral into the atmosphere, and it will burn up in the atmosphere. And so we actually do have to go and put a little rocket motor on it, so it burns up and goes into the Pacific Ocean rather than hitting, a city somewhere. So that's in the NASA plan.
So we won't see it in the Smithsonian Air and Space Museum.
Well, that would be nice, but very difficult.
Yeah. Okay, we have time for a couple more questions.
Okay, a couple of questions. Here is one we wanted to ask. Have you seen Comet Neowise?
Oh, I confess I have not yet seen it.
Meg, can you start with just a quick, just one summary of just what it is?
Yes. So Comet Neowise is a comet that was discovered by the WISE telescope. This is an infrared survey telescope that's out there looking for comets or asteroids that might impact the Earth. So it's a sort of a Earth protection patrol. And they discovered this comet Neowise, which is not going to intersect the Earth. We're not in any danger from it, but it's a pretty bright comet as comets go, and it's near the sun now. It's actually moving away from the sun. So if you go out in the early evening and look toward the horizon, you should be able to see it. Unfortunately, it's raining here in New England where I am, and so I have not had a chance to catch it. John, have you seen it?
So I went out about a week ago in the early morning, and before the sun rose, used my little chart and looked for it, and it was spectacular. It's real tiny little comet, but just the idea that here's this interloper into the inner solar system, a ball of ice about 5 kilometers across with a huge tail, because the sun is boiling off this ice, traveling really fast. But of course, in the sky, you don't see it move, but it looks like it could be moving, kind of a greenish tint. And I saw it then, and then I've gone out a couple of nights now after it went around the sun and it's heading, back out, and seen it. It's pretty hard. I live in Colorado, so it's beautiful dark skies, and it's getting very hard to see. Tomorrow night, it'll be closest to Earth. So if folks go and they look about an hour after sunset, find the Big Dipper and look straight down, and maybe with binoculars scan back and forth, you should still be able to see it for a couple more nights. But I can guarantee it's not the only comet that'll be around. We'll find another one. So if you miss it, try and see it next time. But it is a reminder that, as Hubble has seen, and ground-based telescopes and astronomers know, the night sky is not a bunch of points of light that never change. It's always changing. There's always something new. And we live in a very dynamic solar system. And if you want another example of that, just ask the dinosaurs.
Which we can do because they're still around as birds. So technically you could actually still do that. Okay, another question.
Another question from Dan. What would you recommend for someone without a college degree to do to get involved with astronomy?
Oh, I have an answer for that. So in the last decade, there's been an amazing explosion of astronomy online. It's called Citizen Science. One of the original projects is called Galaxy Zoo, but now there's the Zooniverse. So sorry, Galaxy Zoo was the original, and then they turned it into the Zooniverse that does more than astronomy. But if you go to galaxyzoo.org, you'll find all kinds of astronomy projects that you can participate in. And your brain is a fantastic analytic machine that works better in many ways than computer programs. And so you can help analyze these data. So either galaxyzoo.org or the Zooniverse, ZOONIVERSE.org. You'll find lots of experiments you can participate in.
In fact, for a while, Meg, couldn't you write your name in the shape of different galaxies at Galaxy Zoo? I tried that the other day and it wasn't working, but because there are so many shapes of galaxies from the deep field, you can use, it's like a galaxy script translator.
It's a galaxy font, and I use it all the time. So you go to writing.galaxy.org, and you type in anything you like, your name, a phrase, and it will bring it back to you in galaxies. It's fantastic.
All right, let's do one more question before we have our final thoughts from Meg and John.
Okay, this question is, how do you prioritize what telescopes look at?
I guess I should take that one too, John, because I used to run the proposal review for Hubble. What we do, as John explained, this telescope is open to the world to use. And so in order to decide what to do, we would issue a call for proposals. We would invite astronomers, anyone around the world, to write a proposal for what they wanted to do with Hubble and why. And then we would invite about 150 astronomers every year to come review these proposals, to rank them. Typically only the top 10% would be accepted. Because there isn't infinite time on the telescope. And then those are the observations that are prioritized for Hubble. So it's an open, peer-reviewed competition.
And Meg, isn't it that what's decided on the time on Hubble is decided at one branch of NASA, and another actually deals with the moving the instrument and the mechanics of it? Is that right?
Well, actually, it's all done from the Space Telescope Science Institute with
it is. Okay.
Technical support from. It's different observatories are handled different ways. Yeah.
Okay.
But this was the biggest project ever, and so it was the first that was designed to have its own institute run it.
Okay.
People who were really experts in Hubble.
So Rebecca, unless there's another question that is just a burning question, which I'm sure. I wish we could get to them all, but we can't. But if you think there's one more, otherwise I think we will do some summary here.
I think, so one last one is there any sound in space?
Oh, let's let John take that one. Okay, excellent.
So once you leave the Earth's atmosphere, the distance between molecules is so great. You know, we call it a vacuum. There actually are molecules there. Behind Meg, those molecules are glowing. The atoms and molecules are glowing. But sound is the compression of air in waves. And, you know, once you get outside, you can't hear, you know, anything because, you know, sound can't propagate. So nobody can hear you scream.
I'd like, as our final thoughts, I'd like John and Meg just to think about what the most indelible image of Hubble is, and then we'll turn it to Bill. But what will always remain, just briefly, either an image or an experience with Hubble. But first, I just want to say, in honor of Hubble's 30th birthday, I was thinking, or 30th anniversary, I was thinking, well, the traditional 30th anniversary gift is pearl. So I thought that I would change my background image here.
There you go. The supernova.
That is, Meg or John, do you want to describe what that is there?
Well, I think it's the supernova echo, is it not?
It's 1987A, yep.
1987A. So,
Well,
no, it's a different one?
yes, but I chose it because it's called the Cosmic String of Pearls. So it fits with the theme of a 30th anniversary, the 30th anniversary of Hubble. There's a beautiful picture taken by the Hubble Space Telescope, which is perhaps appropriate for its 30th anniversary. So finally, John and Meg, and maybe I'll start with you, John, just a last indelible thought. What's going to stay with you about Hubble? There are probably so many things, but can you pick one?
Well, you know, as you have heard, and you know, as you've described to the audience, have a very personal relationship with the Hubble Space Telescope. And in 1999, December, it was my first spacewalk, my third space mission, but my first spacewalk. And as an astronomer, you know, I was in my spacesuit, I was out in the vacuum, I was on the end of the robot arm, and I was moved back towards the Hubble. And there was just a moment where it was almost disbelief that it was really happening. And I actually took in my glove, my finger, and I reached out and I touched Hubble just to make sure it was all real. And then, you know, many years later, 2009, my, you know, final spacewalk with the Hubble Space Telescope, at the very end, as you've heard, I gave Hubble another little tap and a salute and wished it well on its voyage, which is very silly because it's a satellite. It's not, you know, an animal or a human being, but we project our feelings, our emotions onto the Hubble Space Telescope because it has so touched so many lives. It's opened up our view of the universe to everybody on planet Earth. And the last thought that I'll leave you with is, if you look at the image behind me, you know, that's Hubble orbiting the Earth, helping us to unravel the mysteries of the universe. And underneath, of course, in space, there's no up or down, but underneath is our beautiful planet Earth. And from the vantage point of space, I've had the privilege to see how beautiful planet Earth is, what a paradise it is that we live on, but also how perilous is our situation on planet Earth. And I just encourage everyone to think about that a little bit. Certainly in the age of COVID-19, our perilous position, but also to treat the Earth well, because it's the only home we have.
It's lovely. Meg,
Wow.
you have any thoughts, final thoughts?
Hard to follow, but I will say, I mean, that's wonderful. I will say that, you know, looking down on the Earth, which I've never done, too much of a coward, it's the ingenuity of the scientists on Earth and the engineers and their collective action, along with governments and funding agencies and NASA people, that made this remarkable thing, you know, built this remarkable machine, which is in a way the greatest monument to humanity that we could devise. It collects tiny amounts of light, you know, one tiny bit of the light emitted by a star. And from that, we can figure out how old the star is, how massive it is, how it's going to be in the future. I mean, the body of knowledge we have learned as a result of this telescope is remarkable. And I think that, for me, is the most remarkable thing about it, that it just has taken humanity somewhere that we would otherwise never have been able to go.
Well, Meg Uring, John Grunto, what a privilege it was to talk to you tonight. Thank you so much for joining us, and thank you to the audience out there for joining us tonight for this discussion of Hubble and the Roman telescope. I will turn it over to Bill now.
Great. Well, thank you, Molly and Meg and John. What an honor and privilege and a joy to have you both joining us tonight and sharing your experiences and knowledge and wisdom and insights on this amazing telescope and, future telescopes yet to be launched. It was really just terrific. Just so you know, as I said at the very beginning, it's amazing. John, you talked about the beautiful blue planet that you've seen from above that's below Hubble and the image behind you. And around this planet, we had people watching from Virginia, from New Delhi in India, from Mexico, from Chile. We've had them from all over the US, from Seattle, from Colorado, Maryland, Kansas, Puerto Rico, Illinois, Louisiana, Tennessee, Hawaii, Pennsylvania, Nebraska, Arizona, Missouri, Wisconsin. Melbourne and Sydney in Australia both. So amazing. New York, people all over are tuning in and listening to what you've had to say and what you've had to share about your experiences and about Hubble and WFIRST, now the Roman Space Telescope. Really fantastic. I was sorry, I'm going to have to talk to whoever runs the SETI Institute. I realized that as panelists, we were not allowed to cast our vote on the poll. So it just doesn't seem fair. But I have to say that, the first two choices were of course extraordinary, and discovering, the anomaly of what, of dark energy and dark matter that we don't yet understand, but could observe thanks to Hubble. But these were sort of part of experiments that we were trying to do. For me, what was really profound and extraordinary were the deep field images. And to me, they're the sort of the essence of what science and discovery and curiosity are all about. It was like, hey, let's point this telescope at nothing and see what's there. Let's open up the shutter and let's do a long exposure and see what we find. And what we found was, one of the most extraordinary, beautiful, and remarkable and mind expanding images ever taken by any instrument or any camera anywhere. Just amazing. So it's really, really a wonderful story. And it was great to have you share that story with us. And how can you tell a story or even talk about a 30-year mission in 1 hour and make it compelling? But you both managed to do that. And so we're very, very grateful to you. And we're grateful to our audience for the amazing questions. It's unfortunate we can't get to them all, but I wasn't surprised to see, like 100+ questions streaming in during your talk. And, maybe we'll get a chance to address some of them offline and follow up on some of them. But in any case, I do want to also, share and echo your sentiments, John, about our planet. One of the things we say at the SETI Institute, among other places that we study very closely, is Mars. And there are people who want to go to Mars. I think it was Elton John who said, Mars is not a good place to raise your kids. Yeah, John wants to go to Mars. I'd like to go to Mars. But on the other hand, it is not a good plan B for planet Earth. There is no real viable plan B. So we really do need to take care of this one. And I hope people will take John to heart at that and pay attention. So with that, I guess we'll close off tonight's SETI talk. Again, please, everybody in the audience, join me in thanking John and Meg and Molly for this wonderful evening. And we look forward to seeing you next month for another amazing SETI talk and joining our journey. And Meg, I did want to point out, I thought it was really quite spectacular that when you had that amazing animation of the galaxies and their, interactions, and, coupling that with the real images, it was extraordinary that there was an absolute perfect letter S at one point being formed by these interacting galaxies, which of course stands for the SETI Institute. So I want to thank you for sharing that with all of us. In any case, thanks again, John. Thanks, Meg. Thanks, Molly. Thanks everybody for joining us from the SETI Institute and all of us in Mountain View. Take care, live long and prosper. Everybody stay well and stay healthy, be smart, and we'll see you next month for another SETI Talks. Good night,
Great.
everybody.
Bye. Good night.
Right.